Now that we've got the relocation brackets in place and we're ready to move on, part 2 is going to be placing all of the rest of the equipment in that you see behind me. AEV's product line here is the XP Dualsport suspension. This is a 2.5-inch lift, and we're going to start off with the springs. We've got some bump stop components. We've got some new end links for sway bars, and basically everything necessary to achieve that 2.5 inches of lift and maintain a great ride quality while improving off-road performance. Before we get into the installation, I'm going to cover the rest of the parts that come in box for the Dualsport XP suspension. We'll go over the shock choice here in a moment, but starting with everything on the table, one of the most important things here is the online position for the instruction manual. Please take a look at that, as it will help you get through this and do so safely and properly. The rest of the parts here, you're going to find a jack extension, which is one of those things. Once we have the lift, we're going to want to make sure that the factory jack still works. This gives us just that spacing to make sure that we can. It also functions as a wheel chock as well when we use it for other things. All the hardware we have here, we've got the triple rate springs, and I'll spend some more time on these when we actually do the spring portion of the install and show you the difference as we pull out the factory springs. We've got some bump stop relocators. These are actually billet aluminum, and as you can see inside, they have all the ridges to reuse the factory portion of the soft bump stop and screw into that location, and they will give us the extension necessary for having proper engagement at the new ride height. We've got some sway bar end links here that are longer that we're going to work with, sway bar facer that we have. Also, because this is the 370 JL package, we want to make sure that we can recalibrate the tire size for the appropriate gear size that we'll also be putting in this at a later date. Now, we also have a few other parts here on the table, and these are all for relocating things such as the panhard bar, track bar in the rear, to make sure we have proper alignment of all the components and keep that functionality up. And again, I'll spend some time more on the geometry on this system. It is pretty cool what the guys at AEV did to make sure that this package is not only comprehensive, but very functional. For the shocks, we're using a Bilstein XP 8100 series shock. These are a 60mm smooth body design with a 60mm reservoir. This does have that floating dividing piston inside to separate the nitrogen from the gas, and as you can see, the front have hoses and the rear are of a piggyback design. This all comes to the effect of it being an application-specific design for the JL, and it comes with all the necessary parts once we get everything installed. You'll find all the eyelets are actually specific to this application, as is the shock tuning, which AEV worked directly with Bilstein to make sure that the valving matched up to the triple rate springs. Since we're on the topic of shocks, we're going to go ahead and remove the rear shocks here. This requires suspending the vehicle on jack stands or a lift, keeping the differential under control while we take the lower bolt out. In order to get the upper bolt out, we do have to remove this fascia here, and we'll be using this in a later step and making some modifications. But this does expose the bolt at the top, which does have a nut inside the frame, so this is something we just have to put a wrench on and pull out to get out of the way, and then remove the shock body. Next up, we have to loosen all of the control arm bolts. This is the lower control arm, the upper control arm, and do the same for both sides. At this point, what we're doing is we're relieving any of the stress that might be on the bushings that are on the factory control arms, and this will allow for an easier movement of the differential once we have to install and remove the spring. And we also have to loosen the bolts for the track bar. So here you'll see I'm putting a wrench and a socket on both sides of the track bar, and we'll get those bolts loose so that we can drop the differential down uninhibited by any of the bushings that are there. I'm going to go ahead and speed up the loosening on the driver's side, but here I'm going to go ahead and continue with the installation portion of it, which is going to be addressing the sway bar. So first we're going to have to take the factory sway bar links out. Once we get those out, both top and bottom, we're going to move on to putting in the new spacers. So to do that, we have to loosen, and we're going to do this one side at a time, each of the bolts, just so the sway bar drops down far enough that we can put in the AEV supplied spacer. These are going to use the new bolts that they've provided. They are a longer bolt, and we're going to basically go ahead and reinstall this immediately at this time and repeat for the other side. Now we have to unplug the locker connector to the differential. Then I'm going to go ahead and address the brake lines that connect from the frame to the outside end of the axle housing. And I'm going to do this for both sides. This just makes sure that we can move the differential without causing any harm to electrical harnesses and brake line. And as you can see, we can lower the differential now, and nothing is restricting its movement, but we're also not damaging any of those critical parts. Now we have enough space to remove the springs, and we're going to do that for both sides. As I mentioned before, I was going to talk a little bit about the differences between the factory spring and the AEV lifted spring. First and foremost, you are going to expect to see some physical differences, as you're going to assume with a lift that you're going to have a taller spring. But keep in mind that the difference in height of the springs is not necessarily going to be the amount of lift. If the spring rate changes or the pitch of the coils change, it's definitely going to change how the vehicle sits with the amount of weight that's placed on it. And that's what differentiates a triple rate or progressive spring from a linear spring. And keeping in mind that the shock also has to differentiate based upon the overall performance of that spring, so the overall length has to change, the compressed length. All of these factors are anticipated by AEV in the design of this, and in this particular setup, they also worked in conjunction with Bilstein to create a valving that matches the triple rate spring. Moving along with the installation, we now have to remove the track bar completely, get the bolt out. We need to pull the bar out of its current location, and this is going to free up the space we need to put the AEV bracket in. As noted here, you have to orient the bracket in a certain way, and they do have an alignment puck that has to go in the bottom hole. You're going to see me hold that behind here, make sure that it kind of squeezes into place, and I'm going to use the supplied sleeve that comes through the position of where the factory track bar went and place a bolt in it to hold it in place. While I'm working on getting these things lined up, I do want to mention that there's a diagram which specifies what exactly you need to do if you have another application. Again, this is a 3.6 liter and it's reminiscent of what the 2.0 would do. However, if you have a 392 or you have a EcoDiesel, these steps will vary with some specific instructions you'll have to refer back to the manual for. I am using my impact here to make sure that we have the little puck in the back properly seated. And as you can see, I'm tightening up, and this is the second time I've gone through to tighten up the parts and stage. Now that I get the pan hard bar in, I'm going to go ahead and start that bolt. But in the end here, you're going to want to refer to the torque specs of each of these bolts and make sure they're tightened to the appropriate specs, which are all provided in the AEV instruction manual. Moving on to the spring installation, one of the first things I like to do is kind of orient the little rubber isolator in that hole, as it does have a rubber tab that goes into one of the holes for location. It's just a lot easier once you see how that looks to get the spring in its final position. Getting it up there and rotating it into position and setting down on the bottom perch gets you ready to move on to the next step. Now, the right side or the passenger side does have this metal ring that has to be placed on top of the isolator before you put the spring in. So same thing goes with the passenger side. You want to again get that rubber isolator kind of situated, identify where that seat goes through and that little piece of rubber pushes through the metal locator on the top perch, and then place your spring in and on top of that spacer and lower isolator. Now we can jack up the differential to put some pressure on the springs in preparation for installation of the shock absorbers. We don't have to go too far with the pressure, but just enough to make sure everything is seated. Now we're ready to do the shock install, and this will vary based upon which one you have. As you can see, I am running the piggyback remote Reservoir XP 8100 for this build. This one does require that you put the piggyback portion towards the back of the vehicle. You want to make sure you do that with the 8100, but if you have a 5100 or non-reservoir shock, the installation remains the same. Bolt in the top, bolt in the bottom in the stock position, and you're ready to wrap up the shock portion of the installation. Now we just have a couple things to wrap up here. We have to get the sway bar end links in, and these are new, so the hardware is not the factory hardware that you took off. You're going to use the stuff supplied by AEV. You also want to make sure that the orientation is what you see here, with the upper portion moving towards the outside of the vehicle and the lower portion S-ing towards the lower mount. Make sure you get that washer in the appropriate order and use all the supplied hardware. This will be one of your last steps on the rear here, assuming you don't have to do the trimming necessary for the XP 8100 shocks. Here we're just going to install the block spacers that are provided in the kit with the necessary hardware. One thing you will notice, I am using my impact, but I do have it turned down to its lowest setting to make sure we don't deform or damage the Delrin block. This next section is only for those people that are using the XP 8100 Bilstein piggyback shock. It does say in the instruction manual clearance for use. It just doesn't give you any guidelines. So unless you want to go back and forth several times and kind of figure it out on your own, this gives you a reference to the other side I created, and I went through the same process. So here you can see with the measuring tool, I got it about 2 inches down from the edge. I kind of show you where I trace the cut lines and then went through the cutting process. I did speed this up. Again, you can adjust this to the tolerances that you like, but this will at least get you in the ballpark without doing a whole lot of guesswork. So again, ignore this if you do not have an XP 8100 piggyback style shock. This plastic wasn't very thick or very hard, and I found a set of heavy-duty scissors would be more than adequate to cut through it. And basically you're going to trim your way around and then clean up the edges. Here you can see the panel that's been modified, and you can see where it would have interfered with the reservoir shock. And we're going to go ahead and put in the factory retaining screws here, and we'll wrap up the rear section of our installation. Just to note, you're going to have to make a modification to this if you do have the AEV rear bumper with tire carrier that is supplied with the JL350 or 370. Now, this is the section where you're going to do the installation for the geometry correction brackets. I've actually already installed them on this application, and if you haven't seen that video, you can see the link to the video here. And this is where they call out doing the actual correction brackets after the rear suspension has been done and before the remainder of the front suspension has. So if you haven't seen that video, this is the time to go and click and do that portion of the installation and return to this spot so we can wrap up the rest of the front suspension install, including the springs and shocks, and see how the whole project comes together. With the geometry correction brackets installed, we want to make sure that we've left the bolts loose on all the control arms. These are the 4 bolts pictured here on the passenger side. We want to make sure the driver's side ones are also loose. We also want to make sure that the track bar bolts are both loose on either end. None of them are moved, but all of this has to happen to make sure that we can droop the front end low enough to get the springs out and the new springs in their place. First, we have to prep for the axle droop, so we need to go ahead and remove the bracket that holds the brake line and the ABS sensor. That's a 10mm bolt here. Then we got to look at these 2 harnesses. The one on the left is the driver's side locker sensor. This is actually on the differential center housing. The other one is on the center axle tube to the passenger side, and that's the actual locker actuator. And both of those harnesses need to be unplugged and removed from the axle housing so that they can droop and not rip out of the back of the sensors that they're plugged into. Now I'm going to have to make a modification to the lower control arm brake line bracket. And basically all we're going to do here is use a set of channel locks or any device you want to use to bend the material back until that top piece that's bent 90 degrees down on top is almost in plane with the bolt that's in the side of the control arm. Keep in mind this is not exactly where it's going to be. We're going to go to the driver's side and do the same thing, but remember that once we get the vehicle down and it's at ride height, we're going to have to bend this slightly to make sure that there's no contact with the brake line and the upper control arm. Next up, we've got to get the sway bar end links off. The bottom one comes apart pretty straightforward. The top one might be a little bit more complicated. It is a sort of ball joint, so it will spin. Now, you can use a wrench by hand to break it loose, but what I found is you're typically going to want the torque of like an impact, but even still, it's going to spin the shaft, and you're going to need something like a set of pliers to grab that shoulder to pop it out pretty quickly. Now we can remove the shock assembly, and all that's going to require is removing the lower bolt here, and we'll get to the upper in a minute. We don't want to pull that lower bolt out completely until we have a jack underneath the end here to support the weight, and that jack will also allow us to articulate that rear end a little lower under control to make sure that none of those brake lines or electrical lines are getting pulled on in any way that's going to damage them. Once we have the height acceptable to removing the spring, it should simply pull up and off the perch, and you're going to have to finagle it a little bit to kind of unscrew it around the upper perch assembly to get it down and around the bump stop and off the vehicle. Now I'm going to spend a minute here looking at the front coils because they are a little bit different than what we saw in the rear, but the same basic principles. Here you can see the 2 side by side, and the overall length is not much higher, but the spring rate is radically different, the number of coils, and more importantly here, the number of coils changes the pitch. So as we can see, the linear rate here, the gap between the coils is relatively similar, and that's throughout the entire coil spring. When you look at a progressive triple rate, here you're going to find that the gap is going to be 1, smaller, so there's more coils, but 2, the gaps are going to differ as it gets from top to bottom. This is that triple rate spring, and that's what gives you the difference in functionality. Now getting back to the installation, we have to remove the factory bump stop, and we're going to put in the bump stock extender. This is going to be that billet piece and a bolt that's got to drop into the top. So the bottom part here actually goes in quite easily. It's a very nice piece, but what you might find is that the gap to drop the bolt is going to be a little bit long. I found that using a magnet here, going from the bottom and feeding it up and placing the bolt on the magnet and then feeding it down gave me a really quick installation. I didn't have to fight its position and just kind of wiggle and pull it through the hole. And all I had to do here now is put an extension, get a socket on it, and thread up the bottom, and of course just put a torque wrench on it to go ahead and torque it down final here, because it's going to be harder to get to once all the other parts are completely installed. One more thing we have to do that's unique to the passenger side is remove this isolator and install a spacer. If you remember from the rear, we had the same thing. This one we just have to be careful we don't damage the little clocking device there. And you know what, I'm just going to go ahead and put this bump stop in. I forgot to pop that in the last step. It just pushes into the bump stop extension. Now, here's the spacer. It's the same thickness as the one we put in the right rear, and it just locates based upon the cutoff edge. As you can see, and the little pinhole that's on the top of the isolator. The difference is in the front, this goes underneath the plastic, not on top of it. Now we can go ahead and get our spring in. Same thing as the rear. We have the rubber isolator at the top. This one's a lot easier to locate. Obviously you can see this one right in front of your face here. We want to clock it to the spring coil and then find the little hole that that rubber piece pushes into. And once it's all aligned, we're just going to go ahead and use the jack to get it clocked and pushed up into position and under a little bit of load. Now we've got to put in the shock relocation brackets for the lower mount. These are provided by AEV and have 2 mounting bolts. We have one that passes through the middle and down through the hole in the bottom of the factory shock mount. We're going to go ahead and put a nut on that to kind of locate it. And what I like to do is pass through the main bolt in the way that it's supposed to, so that when we tighten up this bolt on the inside, we make sure that the bolt can be pulled out from the outside without too much force. Obviously, if it binds, we don't want the shock not to be installed correctly. But as you can see here, it just helps line up all the holes, so when you do torque everything down, the bolt will go in and out as designed. Now I'm ready to do a shock installation, and of course here I am using the XP 8100, so I do want to do a trial fit. There's always a couple of things with regards to shocks that you need to look at for fitment. One is just to make sure that the eyelet fits into the places it's supposed to go, and two, you want to get the overall height of the differential kind of set so you can get all your bolts aligned. Here, I found there's a little bit of interference at the bottom, and all it's going to take is a grab with a set of channel locks. You can use a crescent wrench, and just even the slightest little bit of pull, and it's going to allow that space to open up, and here it'll allow the eyelet to fit in correctly. It is a little bit more of an issue here, again, kind of trying to make sure that I'm supporting that reservoir, not letting it bounce around in there, but I've got the upper bolt in, I've got the reservoir suspended, and now I can use the jack to raise the differential to get the eyelet holes to line up. Here I'm just using the threads to kind of guide it through, put the wrench on the backside, and get that started. Of course, as with any of the suspension parts here, we're going to want to get a torque wrench on each one of these and get it to specified torque. Now these are all steps that are specific to the XP 8100 shock with remote reservoir. These are all parts that you can skip over unless you're running this particular shock setup. So I will mark this section off so that you can move to the end and finish the other vital steps of torquing and of course placing on end links and a few of the final pieces before you're done with the installation. You saw the lower shock bolt extensions. These are common amongst many lifts, but these are specific to the 8100s. So the installation remains the same as you saw earlier, and those remain untouched. Here also you'll see some brackets and a riv nut. The brackets need to be modified. As you can see here, they were shipped with 2 different size bolt holes because there was an update in the hardware. So this is something that they provide instructions for on how to drill out. And one of the parts we want to do is, of course, make sure that they have rust inhibitor on them because this is going to be raw steel. We want to put some kind of Rust-Oleum or rust preventative paint. And now we've got those brackets and they're dry, we can apply those to the universal holders that Bilstein supplies, which is a nice billet piece to keep the reservoirs mounted to the vehicle. This bracket does use the factory holes in the billet bracket, but it also uses factory holes on the upper part of the frame with the assistance of a riv nut to make everything really just bolt up and look like stock. Now, I did start on the driver's side to get the riv nut in, and for whatever reason I didn't hit the record button on the passenger side, but this is what the instructions show for the positioning of the riv nut. There are several places that you do want to put the riv nut to make sure it lines up correctly, so don't put it in one of the other holes. This one is the specified hole. And just a word of caution, when you are going to use an impact for this, make sure it's on a lower setting. And of course, just pay attention so that you don't strip the threads or over tighten it and pull the actual riv nut through the hole. On this step, just spend a little bit of time so you make sure you don't damage the reservoir. You want to make sure that you've got the Bilstein bracket opened far enough to allow it to slide in easily. But you also want to pay attention to where the hose angle is and making sure that you can tuck it behind things, as you don't want this to catch anything. And that's really the whole purpose of why it's mounted where it is it's remotely out of the way from front strike, from contact with the tire, but we still want to make sure that hose is also tucked away nice and neat. Here's what the finished product looks like when everything's bolted up and tucked away, and you have a really nice look that gives the remote reservoir a little bit of presence at the front of the vehicle, but also protects it from any of the rock strikes and things that might come directly, but more importantly keeps the hose out of the way of the tire, any debris that might enter through the wheel wells. And that concludes the installation specific steps for the XP 8100 series remote reservoir shocks. Now we'll resume the rest of the install for the parts that are necessary to complete and get this thing on the road. We only have a couple of steps left, one of which is getting the sway bar end links on the driver and passenger side. This is as simple as using the new longer length supplied pieces. using the hardware that they've provided and getting the lower bolted in along with the upper, and doing the same to both the passenger and driver's side. The last option we picked here is going to be the Bilstein high pressure stabilizer. So we do have to remove the factory steering stabilizer. Pretty simple. We have a bolt here on the outside and a bolt on the inside. The flag nut's a little bit annoying to get to, but you may have to use a wrench because the flag nut does not keep it from spinning. We are going to replace the complete stabilizer, but we are going to reuse the factory hardware. So that flag nut plus the bolt is going to go back into its original hole in place. And then we'll do the same for the outside, hopefully not dropping the bolt like I did. But here the gas pressurization is going to go ahead and expand that shock back out so that we can align the holes. And then we'll put the nut on the bottom and begin torquing up everything that we have. Now, I use an impact throughout the entire build to assist with time, but I always go back and make sure that I'm using the proper torque spec and a torque wrench where applicable. There are a few of those spots that you can't get to, but ultimately the tools that I use are there to speed up the process, but nothing goes around safety. So when you do see me using a impact to get the nut and bolt kind of cinched, I am coming back, even if it's off camera, making sure that all of these parts are torqued to proper specification. Again, suspension steering, we want to make sure everything is exactly perfect. Last bit here, we want to make sure we plug in all of our electronics, otherwise we're going to get error codes, and of course it's not going to function. Well, if you've made it this far, now it's time to appreciate the work we've got into it. The after side on the left here is with all the suspension components on there. On the right, you see it in its stock configuration. You can definitely notice the height of the fender relative to the bench in the back. You can see the difference of the marker light and distance. You can also see where the frame rail sits relative to the top of the tire. Ultimately, you do achieve a little bit more than the 2.5 inch on the right side, and that's because of those spacers, but all of that will start to make sense if you've got the AEV rear bumper, which definitely puts some more weight along with a full tank of gas. Those things will start to level out. So here's all the data I collected, and this is on each of the 4 corners. And again, consider this is a 2022 Jeep JLU Rubicon with no tow package. So all of those things have some effect on the spring rate. And additionally, this had between 1/3 of a tank and 1/2 a tank. But ultimately, the numbers achieved were all of those that the AEV kit said that they would produce, a 2.5 kit, producing at least 2.5 on all 4 corners, and a slight bias on the right side to accommodate their swing with the bigger tire and, of course, a full tank of gas. So super impressed, and if you guys are too, subscribe to the channel, hit that notification bell, and I'll definitely be making some more evaluation content on not only the suspension parts, but each individual component as I'm getting this in the field and finishing up these installations to see exactly what they do on the trail.